The sonic landscape sound surrounds us. Sound is amazing. It's an invisible force that shapes our experiences and emotions every day. We use it every single day, often without even realizing it. It helps us talk to each other, sharing stories, ideas, and emotions. We use it to listen to music, which can uplift our spirits and bring us joy. Even danger signals, like a car horn, use sound to alert us and keep us safe. Imagine a world without sound. It would be eerily silent and quite unsettling. It would be very different, almost like living in a muted, colorless world. We wouldn't have movies or concerts which rely heavily on sound to create an immersive experience. It would be hard to communicate, making everyday interactions much more challenging. Sound is a big part of our world, enriching our lives in countless ways. Understanding it helps us appreciate things even more, from the science behind it to its practical applications. So let's learn about the science of sound. It's fascinating and full of surprises. Sound lets us experience the world in a richer way, adding depth and dimension to our lives. From the chirping of birds to the laughter of loved ones, sound adds color and emotion to our lives, making every moment more memorable. What is sound exactly? It's all about vibrations. Imagine hitting a drum. The drum head moves back and forth very quickly. This movement is called vibration. When something vibrates, it pushes against the air around it. This push creates waves, just like dropping a pebble in water. These waves are called sound waves. They travel through the air and reach our ears. Our ears and brains work together to interpret these waves as sound. Sound waves are invisible but powerful. They carry energy from the source of the vibration to our ears, allowing us to perceive the world around us. Sound waves are tough. They are invisible, yet they carry so much energy and information. They can travel through many things, from the air we breathe to the water in the oceans, and even through solid objects. Air is the most common medium for sound travel. It's all around us, making it easy for sound to move. Think about hearing a plane overhead. The sound waves travel through the air, reaching our ears and allowing us to hear the roar of the engines. But sound can also travel through water. In fact, it travels faster in water than in air. Whales sing to each other underwater using sound waves to communicate over long distances. And sound can even move through solids like walls. This is why you can sometimes hear noises from the other side of a wall. Sound travels at different speeds, though, depending on the medium it is moving through. It's fastest through solids because the molecules are packed tightly together, allowing the sound waves to move quickly. It's slowest in gases like air, where the molecules are more spread out. Sound travels at approximately 343 meters per second in air, which is relatively slow compared to other media. In water, it travels at 1,481 meters per second, much faster than in air. And in solids like steel, sound can reach speeds of up to 5,960 meters per second, making it the fastest medium for sound travel. Section 4. Frequency and amplitude, pitch and loudness. In this section, we will explore how these two fundamental properties of sound shape our auditory experiences. Have you noticed that sounds can be high or low? That's frequency. Frequency is the number of sound waves that pass a point in 1 second. A high frequency means many sound waves are squeezed together. These waves are closer to each other, resulting in a higher pitch. This makes a high-pitched sound, like a whistle or a flute. High-pitched sounds are often sharp and can be easily distinguished. Low frequency means the waves are more spread out. These waves are farther apart, leading to a lower pitch. This makes a low-pitched sound, like a bass drum. Low-pitched sounds are deeper and can often be felt as much as heard. Amplitude is about how tall the sound wave is. It measures the energy or intensity of the sound. A big, tall wave has a lot of energy. This results in a loud sound, like the booming music at a rock concert. This makes a loud sound. Loud sounds can be powerful and attention-grabbing. A small wave has less energy, so it makes a quiet sound. Quiet sounds are softer and more subtle, like a whisper. Frequency determines the pitch of a sound, while amplitude determines its loudness. Both properties are essential in defining the characteristics of any sound. Together, they create the rich tapestry of sounds we hear every day. From the chirping of birds to the roar of thunder, frequency and amplitude work in harmony to shape our auditory world. Section 5 Sounds Technological Symphony. We use sound in amazing ways. Think about musical instruments. They use vibrations to make different notes and melodies. Ultrasound machines use sound waves to create images inside the human body, helping doctors diagnose and treat illnesses. Sound recording and playback devices, from simple microphones to sophisticated speakers, rely on the principles of sound waves to capture, store, and reproduce audio. From medical imaging to entertainment, sound plays a vital role in countless technologies that enhance our lives. Section 6. Echoes of understanding. Sound is all around us. We've learned that it's made by vibrations, travels in waves, and can be high or low, loud or soft. We've explored how sound travels through different mediums and how it's used in technology. Sound is a fascinating part of our world. Keep listening and keep asking questions. For example, why do you think you hear an echo in an empty room? Science is all about exploring and having fun. By understanding the science of sound, we gain a deeper appreciation for the symphony of sounds that enrich our lives.